Hey guys, welcome to episode 15 of the peer-to-peer network coding session. Today we're going to work on debugging the code that was written to check for permission at the HTTP interface of the network node. Okay, so here we go. So this is the HTTP interface. We already tested the WebSockets interface. We have already configured that this node is a member of a permission network. So we're just going to run this code through here. And we're going to go to the user interface to trading signals demo. So we're going to run this network node and hope it's going to stop at that breakpoint. So here we're just going to just for now run the trading bot that is going to be sending the signals. Yeah, and then I'm going to send this from here. Okay, and the signal is... Oh my god, this is not running. Oh no, yes, it's running. What happened with the signal? Peer not available at the moment. Okay, it seems that it seems like we are not connected to any network node because I see this guy retrying. Okay, and the reason for that is that if we go to the environment file, that we have it somewhere here. What we have is that the task server is pointing to a peer-to-peer network testnet and not to a permission peer-to-peer network called BATA. So because of this, there is no connectivity. And for instance, our test was not working. So let's try this again. Okay, now we have this connect via HTTP. Not connected, but we detected the node. And WebSocket is connected also. So good. Next thing we're going to do is to run this. And here we have it. So the filter for network type was good. So now we're going to check the permission. And we have permission to connect. That means that this is working. Okay, so we will receive more requests. What's going on here? Okay, we will continue the debugging. So we will get into here. Okay, it says headers, HTTP headers sent. Cannot set header after they are sent to the client. Okay. And it's because an error occurred. Okay, so we'll just debug this stuff. So we are inside of message receive client interface for trading signals. So my guess is that something is not working in there. Okay, inside here all is good. And that was one of the things we wanted to debug. So broadcast to clients is probably failing. What is going on? Here I will take a note of something we need to do at the network, that is broadcast to clients should take into account not only the WebSockets clients connected, but also if they are not network nodes, there if they are following the social trading bot emitting the signal. Okay, so today we are broadcasting the signal to whoever is connected to this node, and that is a kind of simplification of. So where are we? Okay. So there is one network client connected. Okay. This is returning true. The response is okay. Okay, so we are going to respond with content. Break, break. Okay, this is repeated. We shouldn't respond with content because we already respond with content for all the possible paths. Okay, so we don't need this. Okay, so the debugging is finished. I would like to make a test to make sure that everything is working perfectly well. I'm going to come to the platform, my data storage, project, algorithmic trading, and delete everything there. Then I will go into here. So now for this test, we are going to run both tasks, the emitting and the receiving signals, sending and receiving. Okay, both are running. What is going on with this? Well, there's a bug here. When I put focus on this, then it never came down. It never comes down. Okay. So this will wait for the signal and this will send the signal. my god. Okay. I think that I should run the test again because those breakpoints didn't help at all. So again, we are going to delete all this. Okay, here it goes. Finish sending the signals. This guy is receiving the signals of the whole day. And it seems to be working. So we're going to stop all this and check the charts. And the chart looks well. Both strategies are there and both have all the candles and all the stuff in place. So amazing. It was very easy. So we're going to commit this with HTTP interface debugging, checking for permissions. Okay, so that's good. So what is the next problem to solve? According to my notes, the next thing to do is to filter, is to not to connect to the nodes that we don't have permission to, which makes a lot of sense. So for that, what we're going to use is, we have the desktop app somewhere here. Desktop app, okay. So here is the desktop app loaded with some of the modules that make this happen. So we have the desktop root, we're going to put it there, desktop app. Then we have one guy called like peer-to-peer network, a socket network client and network peers. Okay, so the network is the one who builds this array of peer-to-peer nodes to connect, and peers is the one actually doing the connection. So what we're going to do here is to filter out, and this we have to do it both first for um, we need to do this for WebSocket, and then for HTTP. Okay. Okay, so here is where we are checking or filtering out the networks that are not of the type or the name that we are supposed to connect to. On the other side, on the other side, if we are on a peer-to-peer permission network, we know that we have a permission granted by user profile ID. Hold on, because this is something that I'm not clear in my mind. This map of permissions, we did it for when we were running a network node. Okay. Let me review this. Okay. So at the end of the bootstrapping process, if you are running a peer-to-peer network node, okay, so we will have this only set up if we are running a peer-to-peer network node. That means we cannot use this. We cannot use this stuff as of right now. So how do we know? How do we know? Here we are sending the network we are trying to connect to. And from there, we're getting all the permissions. Okay. So how do we know here? The first thing we need to know is if we are in the situation where this peer-to-peer network node. Okay, this is the network node we are going to connect to. And this is the network code name and network type. Okay, good. So if the node is of the same network and network type, then what we have essentially is a node like a referent to this node. Okay. So how do we know? Also, we can have a reference to the permission peer-to-peer network node. Okay. That is this. So what we need to do is the following. If this probably if this is equal to permissioned peer-to-peer network, then we're going to do this, and if not, then we just use the node, because if it is a permission, then we are going to check if we do have the permissions. Okay. Okay, so if it is a permission peer-to-peer network, then we are going to do something similar to here. So we're going to give it as an initial node, the network node, and check for all the children or grandchildren permission granted. Once we have that array, we got to know we gotta know if any of these guys, okay, so now we can see these guys, this guy. So we will have an array of this guy. So we need to compare the reference parent ID So permission array. So if 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 is equal to our own ID, the user profile of who we are running as, that I will get it from here. Desktop app, this object, peer-to-peer network identity. So where this is the user profile ID of who is running the desktop app in this case, or whatever app. There is something missing here. One of these guys. Yes. So essentially, this is the validation logic. Okay, the problem is I cannot use TK here because this is not dependent on the desktop app. So I will have to receive this as a parameter. Peer-to-peer client network identity. Okay, and exactly the same thing we are going to do here. Maybe I should create a function for this so not to repeat so much code. Um, Okay, so it seems only one parameter is needed, and it's the network node that we are actually processing. So we can do this, check for permissions here, and if this ID is not equal to this, then we check for permissions here. And this is our logic. If we are inside a peer, or if this node belongs to a permission peer-to-peer network, if not, we add the node to the list. Otherwise, we are going to, from that peer-to-peer network, we're going to gather all these nodes as an array that we iterate and see if any of the permissions are pointing to our own network identity. But we will need this here. So who is calling this guy peer-to-peer network? I guess we'll need to modify all these instances of this, wherever they are. Probably. Okay. Now I see them all. So in these cases, we will send this guy, and this guy. But in this case, we don't have this network identity, but we have peer-to-peer network node that is the equivalent to that. Okay, so let's test our code now. So we'll come up to here. We have a network node there, and let's try this out. Okay. Okay, again. Okay, so we have a node candidate to connect to. Network node 1 of my profile. And we're going to check if we have permission. So the network node is a permission peer-to-peer network. So we will get an array of all the permissions. There is only one. If this is undefined, we continue, otherwise we check this is not good. User profile here. There is something wrong here. And I believe it is a user social profile and not a user profile. Yeah, so this is not going to work, and we are not going to have permissions. Okay, and this is going to be stuck here without actually connecting to anyone. So why we still carry this problem? Because this is inverted. Okay, let's try it again. Check for permissions. It's the same ID, the only permission, but good. So here we are where WebSocket client connect to network node via WebSocket. Wonderful. So we are filtering out the nodes that we don't actually have permission to, which was the goal of all this stuff. Okay, so we are going to commit these changes. Filtering out. We are talking about WebSockets. WebSockets. Okay. So for WebSockets, done. What's next for HTTP? For this, instead of this peer-to-peer network, we are using another module that is called peer-to-peer network start. Okay. Okay, no, we already solved it because this is true for both. HTTP also uses peer-to-peer networks to connect, which is the array of nodes. That means that if we didn't put it into this array, then it's not going to be available for peer-to-peer network start. Okay, so we automatically filter out both WebSocket and HTTP network nodes that we don't have permission to, which is kind of awesome. So at our nodes, what is left is nothing regarding this topic. Okay, So let's recap. What we have done at this session is to verify at the client side that we are not even trying to connect to a network node that belongs to a permission peer-to-peer network that we don't have access to. Okay, not even trying. Before that, we check both at the WebSocket interface and the HTTP interface that any connecting entity client, if the node is part of a permission peer-to-peer network, needs to have permission granted for that network. Otherwise, it will not connect. So with this, the topic of peer-to-peer permissions network is done 100% and is tested. So at the next video, I will be looking into broadcasting signals that only should be broadcasted towards clients that are following these signals. Okay, so that is what we're going to be doing at the next episode. So thank you for watching and see you next time. Bye.